Math 3, Unit 8, Lesson 5, Transformations of Trigonometric Functions. Transformations performed on any function f of x to form a new function g of x can be described by the transformation function form g of x equals a times f of b of x minus c plus d. Each letter, a, b, c, and d, are in charge of different transformations outlined in the table below. The a value in front of the function is in charge of a vertical stretch, a vertical compression, or a reflection across the x-axis. So if a is greater than 1, you're going to have a vertical stretch. So as an example in the far right, if you had something like f of x equals 4 sine x, since 4 is greater than 1, that would be a vertical stretch by a factor of 4. For the next row down, if a is in between 0 and 1, that's going to be a vertical compression. So say you had something like f of x equals 1/2 sine x, that would be a vertical compression by a factor of a half. Say we had a negative a value, so f of x equals negative sine x, that would be a reflection over the x-axis. The b value is in front of the x but inside the parentheses, and those are going to be your horizontal compressions and stretches. Everything's always backwards with the horizontal transformations. So if b is greater than 1, that's actually going to be a horizontal compression. So something like this. F of x equals sine of 4x. That would actually be a horizontal compression by a factor of 1/4. Say we had something like this, where you do sine of 1/4 x, so the b value is in between 0 and 1, that would be a horizontal stretch by a factor of 1/1/4, which simplifies down to 4. So it would be a horizontal stretch of 4. With the b value still, if it's negative, that's a reflection across the x-axis. So something like this. F of x equals sine of negative x. You would reflect over the y-axis. The c value is inside the parentheses after the x. It's either being added or subtracted from the x value. You'll notice built into the function there's a minus sign. So that's why the horizontal translations are always the opposite of what we think they should be. So if we see something like this, so f of x equals sine x, and then we go minus 5, that would actually be a horizontal translation to the right 5. So we see the negative 5, but we actually go right 5. It's because of the built-in minus sign back here in the formula. If I did something like f of x equals sine of x plus pi, that would be a horizontal translation to the left pi units. I threw the pi in there because typically with periodic functions, you actually work in a new unit called radians. So you could have a pi or pi over 2 or 7 pi. You often actually work with pi's, so I threw that in there so you could start getting used to seeing that. The last one, the vertical translations, those are as they should be. So up is positive, down is negative. So I could do f of x equals sine x and then plus 1. That would be a vertical translation up 1. Or I could do something like f of x equals sine x minus 3. That would be a vertical translation down 3. Consider each transformation to f of x equals sine of x. List each transformation used to change f of x into g of x. So the 4 in the front here is your vertical stretch by a factor of 4. And then that plus 3 is not inside the parentheses, so that's a vertical translation up 3. On number 2, there is the negative sign in the front, so that corresponds with your A value, so that's a reflection over the x-axis. And then the minus 4, since it's inside the parentheses, that's going to be horizontal. So it's a horizontal translation. Remember, it's always the opposite of what we think it should be. So horizontal translation, right 4. I would say pause the video and try the next 2. On number 3, that 2 inside the parentheses has to be horizontal, and those are always the opposite of what we think it should be. So it's actually a compression since the B value is greater than 1. So this is a horizontal compression by a factor of a half, because it's by a factor of 1 over B, if you look back at the table. And then the minus 3 should be a vertical translation down 3. On 4, the minus sign in the very front is your reflection over the x-axis. Your 0.5 is in between 0 and 1, so that would be a vertical compression. By a factor of 0.5. The plus 1 is inside the parentheses, so that's going to be horizontal. It's always the opposite of what we think it should be. I'm getting a little short on space, so I'm going to abbreviate horizontal HOR, and then translation like that. So horizontal translation left 1. And then that last one, since it's not in the parentheses, that's a vertical. I'm going to abbreviate vertical. And then translation, I'm going to abbreviate that as well. And then down 2. Pause the video and try 5 and 6. So on 5, the negative in the front is your reflection over the x-axis. So that's your A value. The 3, it's greater than 1, so it's a stretch, a vertical stretch. By a factor of 3. Your plus 2 is inside the parentheses, so that's a horizontal translation, always the opposite of what we think it should be. So horizontal translation left 2. And then that last one, the minus 1, is a vertical translation down 1. And hopefully you're noticing all these transformations that you've done a million times this year, everything's always the same. We're just changing the function type. We've done radical equations, we've done cubic functions, quadratic functions, all sorts of different types of transformations on all different types of functions. And everything's always the same. On number 6, the minus sign in the front is a reflection over the x-axis. The 1/4 is inside the parentheses. It's in between 0 and 1. So that's actually a horizontal stretch. Because the horizontal the horizontal transformations are always backwards. So that's going to be a horizontal stretch by a factor of 4. Because it's by a factor of 1 over absolute value of B. So 1 over 1/4 is actually the same as 4. And then that plus 3 in the back is just up 3. So vertical translation up 3. Pause the video, try 7 and 8. On 7, that negative sign is your reflection over the x-axis. That just means the whole function, the whole graph, flips upside down, basically. The 2.5, that's a larger than 1, so that's a vertical stretch. By a factor of 2.5. The minus 90 would be right 90, so horizontal translation right 90. And then the minus 1 would be down 1, so vertical translation down 1. On 8, that minus sign in the front is your reflection over the x-axis. The 1/2 is in between 0 and 1, so that's a vertical compression by a half. And then, that's going to be way too light. And then your plus 60, that would be left 60, because it's inside the parentheses. It's always the opposite of what we think it should be when it's inside the parentheses. So horizontal translation left 60. And then the plus 7 would be up 7. So vertical translation up 7. And then the last little part of the notes here, we have the equation for a periodic function m of x is given. The equation for the transformed function t of x in terms of m of x is also given. Describe the transformations on m of x that produces t of x. Then write a periodic equation for t of x. So we'll do 9 together, and then you could try 10 and 11 when you pause the video. So on 9, the parent function is cosine x. And then as far as the transformations go, since 0.5 is in between 0 and 1, that's a vertical compression by a factor of 0.5. So vertical compression by 0.5. The plus 3 is inside the parentheses, so that's a horizontal translation. Always the opposite, so left 3. And as far as writing an equation goes, we want to name the function t of x, because that's the new function. And then basically I'm just going to say 0.5. And then instead of the m, I'll put in the cosine. And then instead of just the x, my new input value is x plus 3. So basically the only difference between what they originally gave us right here for t of x, the only difference is instead of the m, I'm putting in cosine. And then everything else just stays in the same spot. Pause the video, try 10 and 11. On 10, the parent function is cosine x. And then we have this minus sign that is a reflection over the x-axis. And then we have the 4. And since 4 is greater than 1, that's actually a horizontal compression, because everything with horizontal is backwards. So horizontal compression by a factor of 1 over 4, because it's supposed to be 1 over b. And then that minus 1 in the back should just be down 1. So vertical translation down 1. And as far as the equation goes, we want to still call it t of x. And then basically the only difference is instead of the m, I'm going to put in cosine because cosine was the parent function. Everything else I'll just leave in the same spot. So the minus sign is still in front. Cosine's going in instead of m. The 4x is still inside the parentheses, and then the minus 1 is still in the back, not inside the parentheses. All right, last one. Parent function is sine this time. The 2 is your vertical stretch in the front. So vertical stretch by a factor of 2. I don't think we've seen one of these yet on this worksheet, except for the very first page. When the minus sign is inside the parentheses, that's when you reflect over the y-axis instead of over the x-axis. So reflection over y-axis. And then the plus 5 is just up 5. So vertical translation up 5. And then as far as the final equation goes, I have t of x equals, and everything's going to stay the same, except wherever I see an m, I'm going to replace it with sine, because sine was the parent function. So 2 stays in front, and then I put in sine negative x plus 5. And that's all.